So compound interest. So this is what causes everything to grow real fast. This is a summary of Chapter 3 from the textbook. You can see there's problems from 3.5, number 3, number 4, 3.6, number 2, 3.7, and 3.8. So this is just a summary of a bunch of different sections in the textbook about how to calculate compound interest. Now, the formula is really, if you go to the second tab here, 3-5, is really, starts getting really big right here. But instead of doing it this way and having you guys calculate it by hand, I'm just going to have you use online calculators. Chances are in the future, when you need to calculate interest, you're not going to go and say, like, what's the formula? I need to write this down and calculate something. You're just going to Google financial calculator. So if you go down to the bottom here, there is a link to a calculator. And then you can calculate the interest very quickly. Okay? So find that. Open up this link. There we go. And we'll just use these calculators to calculate the different interests as we go along. So you can practice with this example. Put in the principal of 1,650. At a rate of 3%. It's compounded daily, I think is what it said. 360. And it says the time is 3 years. T equals 3. And you can see down here it says that will turn into $1,805.38. The exact same number we get from this formula, $1,805.38. Now, what are all these different little options and everything, and why do they exist? Let me mention a few things. So, this is giving you, you saw yesterday on your other assignment that some of the questions ask, well, how much money will you have? What's your balance? So it's the principal plus how much interest you made off that principal. That's what this says right here, P plus I. If you just want to know what the interest is, you can change it and say, I just want to know what the interest is, right? And it'll give you just that amount. But usually we want to know how much you have in the bank, basically. So we put P plus I there. Now for compounding, there's different ways of compounding. You can compound once a year, twice a year, 3 times a year, 24 times a year. 24 would be the semi-weekly, right? So, or semi-monthly. So there's different ways of compounding. Usually it's daily or continuously, right? Now, how come there are 2 different options for daily? There's 360 and there's 365. Obviously, there's 365 days in the year. How come there's this 360 option? Anybody have any ideas about, this is banking. Why would it be missing 5 days? Yeah. What's that? Holidays. There are banking holidays. There are certain days that the stock market is closed. There's 5 of them in a year. That there's no trading, there's no nothing. So that's why there's an option for that. Good, good, good. So it could be, it doesn't change it too much if you just put in 365, hit calculate. Right? It really doesn't even change it that much. It says it's actually the same amount. So when you're dealing with only like a little bit of money, you're not even going to see a difference on just those 5 days. Just so you know. If I change it to continuously, it went up by 1 penny. So you better believe, though, credit card companies are going to charge you the one that gets you that charges you the extra penny. So they usually go with continuously. Just so you know. So do yourself, go ahead and do the check your understanding. Let's just make sure you're knowing how to use it. It says $2,350 in account that makes 3.1% compounded monthly. What's the ending balance after 5 years? So just go ahead and put in those numbers. So we got $2,350. I think it was 3.1% compounded monthly. Go down to monthly, 12 times a year. And it was for 5 years. So you can see down here, 5 years gets you about $400 of free money, $393.45. Okay, not too bad. So this is for 3.5. Now back on the homework right here, there's 2 problems from 3.5. So it kind of tells you ahead of time which of these calculators you need to use. So you know for these 2 problems that are from 3.5, number 3 and number 4, you're going to be using this calculator or this link right here. Okay, so it gives you ahead of time what to look for. All right, and let's just go do the same thing for each one of these. So now we have continuous compounding. Now the last one did have that option, but I'm just going to use a different screen here because it shows the actual formula. Now one thing that you're not going to see in Algebra 2 that you would have normally seen if you took just the regular Algebra 2, or if you already took Algebra 2, you might recognize some of this stuff. But there's this letter here, E. Now that letter E is not really a letter, it's a number. It's kind of like pi, which is 3.14159,852 and all that stuff. E is a number as well. It's like 2.7832, right? And it's a number that occurs in finances and a lot of other things that predicts or gives us the continual growth. So that's what this letter E is. You see over here in this formula there's also this LIM with an X and an arrow and infinity. That means limit, something you actually see in calculus. So the financial ways of calculating things have a lot of higher math in them. It's not just basic math only. Okay? But we can use these calculators once again to calculate interest, right? And there's a bunch of them. If you just Google compound interest calculator or continuous compound interest calculator, there'll be a bunch of them. But this just gives a nice illustration of what everything stands for, all the different variables. It has all the same stuff, the rate, the time, the principal. It just has this new mathematical constant E that's normally you don't see in any other type of calculation. So, if I wanted to try this out, I could put in, let's see here, $1,000 at 4.3% compounded continuously after 5 years. So 1,000, 4.3, 5 years. So I can say my starting amount is 1,000, my rate 4.3, okay. Time is after 5 years. Don't need this at all. And then right below, you see the calculation automatically pop up. It also gives the formula with all the calculations. There's this letter E. Like I mentioned, it's not just a variable. It's not a variable where you substitute a number. It's always 2.718281828. It's always the case. 2.718281828. And if you look on a scientific calculator, there's usually a button that is just the letter E, and that's what it stands for. So we can practice here and say 5,000 at 5.12% for 4 years. That's what the check your understanding down here. So we can change this to 5,000. 5.12%. 4 years. And that calculates it for us and says $6,136.40. So $5,000 in 4 years gets you a little over $1,000 of free money. Or if this is credit cards, this is how much more you're paying. You're being charged as much because those credit card interests are really high. The difference is with credit card payments, they're not 5.12%. They're usually like 20%. So $5,000 is now costing you $11,000. This is why you don't want to use credit cards, because that interest rate for credit cards is like 20%, but the interest rate for like investments can be like 5%. A credit card charge you a lot more than you get in your investments for that reason. It makes so much more money for them. Okay. So this is the compounding continuously. If you go back to here, here's compounding all the different ways. Annually, semi-annually, quarterly, monthly, daily, hourly. If you want to do the hourly, minute, but you don't need to. And then there's continuously. And then at the very end, it just asks you, what's the difference between the simple that you started at the very beginning, that's what the last homework assignment you did is, and the compounding continuously. Just how much more money do you owe with continuous compared to simple? And that answers the question of, well, how come credit cards don't charge simple interest? How come continuously compounding? They get more money out of you, that's why. But just exactly how much is what you're going to find out. Now, so for these questions, A, B, C, D, E, and E, right, you can use, let's see here, you can use this one, because you can toggle this to however you want to compound it. And then for the continuous, you can use this one. For that last question, you can use this one. So those questions, those A, B, C, all those letters are just a combination of 3, 6, and 3, 7. Now there's two other types of questions, and that's what these last two are, from 3.7 and 3.8. And they're big formulas. And it basically says, what will your balance be in the future? What's the future value of something? So suppose you have $1,000 deposited in an account that's 5% interest, compounded annually. How much money will be there at the end of 4 years? Just how much money will be there in the future? The last question is, how much money, you want to have a certain amount of money. Rich needs $50,000 for a down payment in 5 years. How much must he deposit if he has 6% interest compounded quarterly to make sure that happens? So this is figuring out, what does that principal need to be? If I need to have $50,000 because that's the minimum for a down payment, how much do I need to start off with if I know I'm getting 6%? So those are the other two questions. That's what this future value is right here. And if you look at the formula, it starts getting a little more difficult. You can imagine back in the day, before all these fancy internet calculators and everything, that this was quite a bit of work. You know, for someone to calculate all this stuff and, you know, get the right answer and advise their clients and all that, you know, it was quite a lot of work they had to do very carefully. So luckily for you guys, you just need to know what the right tool is and where to find it online. Not really have to do it by hand. Okay. Even at the time of this book, things like this did not really exist, and when this book was first published, all the students were writing everything out by hand and calculating everything by hand. Which luckily we do not need to do any longer. So once again, the link is right below. You can click on this one. You may not know what all these different things might mean, but just follow along the examples I've given you. There it is. And this one says the interest is 4.5% annual for 20 years, right? With a $5,000 principal. $4.5, 20. $5,000. And below, it will give a nice table, and it says how much it goes up by each year. Now, you know you're getting interest plus you're putting in money, right? So this is what it does. It tells you exactly how much interest you get each year. And you can see how fast it grows. First year you only get like $19 of interest. After the 10th year, you're getting $1,000 of free money. So you can, again, see, notice how it takes like 15 years to really start growing quickly. Like it's only going up by very little, by very little. All of a sudden, it's in the thousands, and then from year 15 to year like 19, within 4 years, you're going from 2,000 to 3,200. It grows a lot faster because you have a lot more money. Okay. So it gives you this nice chart that says what number a year, how much money you'll be making, and an overall percentage that you're getting. You'll notice how that keeps going up and up and up. Oops. Get out of there. There we go. So you can use that calculator, or any others that you just Google future value calculator would work as well. And you go back here and then just type in the numbers from this particular problem. Just like the example, it says $1,000, 5% interest at 4 years. So, and the last question is right here. Let's say you want to have $100,000 in savings account after 10 years, and we know the rate is 3.8%. How much do we need to start off with? So it's 3.8%. We want to have a future value of $1,000. This is also a great calculator of, I want to retire with this much money. What do I need to start with now? What do I need to do right now to make sure I end up with this much money? Okay. And this particular problem is 10 years, and it's compounded daily. After 10 years, I want to have that goal reached, and it's compounded daily. All right. So turns out you have to start off with quite a bit in order to get that amount. You have to start off with $68,000. Put that much away right now, and that will end you with $100,000 in 10 years if it's at 3.8%. Now, this is a very low rate. If you're really doing this, your investment would be something much better than this, because 10 years you can leave it alone, not touch it. You could put it in something that's actually getting closer to 15% in reality. And if it's 15%, you can see you only need $22,000. So that interest rate, when you hear a lot of news about, oh, rates are up, rates are down, it makes a big difference. From 3, or basically 3.8, which is 4%. From 4% to 15%, it goes from $68,000. Like, who has $68,000 just sitting there? Not many people. $22,000? Well, that's a lot more doable to save up for relatively quickly, especially if you have a good career job. You're making $70,000, $80,000. You know, you can save that up and come up with that, right? So that's why interest rates are such a big deal when we talk about investments and the stock market. Changes everything. Okay? Not sure why that keeps clicking. Here's the fairly complex formula. So if you're interested, doing this by hand, go for it. But otherwise, just want you to know about these different online calculators that exist, and they can help you out when you're trying to compute things. Okay. So all you need to do is use those 4 calculators, or any others that do the exact same thing, to answer these questions right here. I put 2 bonus here because it's not an option. On the calculators, you would have to do those by hand. So you don't have to do G&H, which says compound hourly, which no one really does. Compound by the minute, which nobody really does. So it's usually compounded annually, semi-annually, quarterly, monthly, or continuously. All right, so I'll leave you with that. Just put your answers right here where it's yellow. Answer for number 3, number 4, A, B, C, D, E, F. Skip G and H, do I and J. This one is just a subtraction problem. So J just equals whatever I minus A is. So what's the difference? Remember, difference means subtraction. So what's the difference between simple and compounding continuously? So compounding continuously is I, simple is A. So all you need to do is the answer for I minus the answer for A, and you'll know how much more you're charged for compounded continuously. Okay, so that will get you through that, and let me know if you have any questions.